Hello. I suppose the videos that I have been uploading till now was quite effective and helpful for each one of you, those who have subscribed my video. I would like to thank once again all of you, and I would request all of you once again to share my video and the channel as much as possible. Today I am here to explain a topic of class 11, that is periodic function and the periodic how a trigonometric function behaves like a periodic function. So let us understand what is the definition of periodic function. First of all, if a function fx equal to f of x plus p where x belongs to the domain of f for any number p. If a function behaves in such a way so that f of x is equal to f of x plus p, where x belongs to the domain of f, now this value of p may be more than 1. Then the least value of p is known as the period of fx. This is the definition of periodic function. Means we will get a number for which f of x plus p, whatever functional value we get, and f of x will be same. Means after certain period the number or the function repeats its value. So let us understand how a trigonometric function also behaves like a periodic function. For that, let us consider a circle. Now, this is the origin. This is x-axis. Suppose this point P is AB and the length of this arc AP is x. If the radius of this circle is 1, or we can say that we have considered a unit circle, then the circumference of circle is 2 pi into 1, that is 2 pi. Let me repeat what I have considered. I have considered a unit circle, that means a circle with radius 1, and P I have considered a point on the circle with coordinate AP. If the arc length of AP is x, and from this P I start moving on the circle so that I cover a distance of 2 pi. I start from P and again I cover a distance of 2 pi. That means if I cover 2 pi, that means I am covering 360 degree. So x plus 2 pi I have covered. That means if I start from P and move a distance of 2 pi, I come back to the same point P. If I come back to the same point P, that shows that the function f of x plus 2 pi is same as f of x. In that case, if I draw a line perpendicular here, then this is B and this is A. Then sine of x equal to, since this arc is x, so the angle will be also x, sine x will be B by 1. And this x and x plus 2 pi, they are the same distance covered. Therefore, sine x plus 2 pi will be also b. This shows that sin x equal to sin x plus 2 pi. So the trigonometric values of sine at x and the trigonometric value of sine at x plus 2 pi is same. That means the periodicity of the trigonometric function sine x is 2 pi. Let us consider cos also. Cos x is a by 1, base by hypotenuse, and cos x plus 2 pi will be also a by 1. That shows that cos x is also equal to cos x plus 2 pi. Or in other words, we can say that whatever the value of sine x is, the same value we will get when we add 2 pi with x and get same thing. For example, sine 30. If we know it is half, then if I add 2 pi with 30, 2 pi means 360 degree in terms of degree, pi is in radians, so sine 30 degree plus 360 degree, that is sine 390 degree, will be also half. So what we conclude? That sine 30 and sine 390 are having equal values, because after one circle or one round it gives the same trigonometric value. Now this was the definition of periodicity of sin x and cos x. The same rule is applied for tan, sec, cosec and cot. Now let us understand the sign of trigonometric functions. Sine. Sign of trigonometric function. Again, let us consider an unit circle. A circle with radius 1, with the center at the origin. If I again consider this point P, AB, then this angle, let it be theta, and this is B, this is A. If I join below, this is measured in anti-clockwise direction, this is measured in clockwise direction. So in triangle OPM, this is likely to be Q, in triangle OPM, sine theta is B by 1 because hypotenuse is 1, and in triangle OMQ, it will be sine of minus theta. That will be below it is. So it is minus A minus B will be the coordinate. So it will be minus B by 1. So what we get the relation from here, that is sine theta is B, and this is equal to minus of sine minus theta, or we can simplify and write sine of minus theta equal to minus sine theta. Now for the case of cos, cos theta equal to A, and the same way when we take in triangle OMQ, cos of minus theta will be same thing, because here we are not interested about the y coordinate, only the x coordinate it is, and it does not change, so it is A. So cos theta is equal to cos of minus theta. So we get two relations. Sine of minus theta is minus sine theta, and cos of theta is equal to cos of minus theta. Now if we know sine and cos, now we can find its reciprocal, that is cosec of minus theta will be minus cosec theta, and sec of minus theta will be sec theta. For tan, the rule for sine tan is same. Tan of minus theta is minus tan theta, and cot of minus theta is minus cot theta. This is the sign of the trigonometric function, how it behaves when we take the angle in clockwise direction or in anti-clockwise direction. Now one more point to how to find out the value of the angles when it is more than 360 degree or greater values, that we should understand. Now if I take this plane and divide into 4 parts or 490 degrees, we have 0 to 90, 90 to 180, 180 to 270, and 270 to 360. So I have divided the whole quadrant into whole plane into 4 quadrants. This is first quadrant, this is second quadrant, this is third quadrant, this is fourth, into 4 parts. Here both x axis and y axis, they are having positive sides, positive axis. So the value of the x coordinate and y coordinate both are positive. Here x is negative, y is positive. Here x is negative, y is negative. Here x is positive, y is negative. If here it is both are positive, if both are positive, that means the perpendicular will be also positive and the base will be also positive. So if perpendicular and base are positive, then all the trigonometric ratios will have the values in between 0 and 90 degree positive values. Here the base is negative and the perpendicular is positive. Perpendicular positive means we know sine theta is perpendicular by hypotenuse. So if perpendicular is positive, that means sine theta will be positive, and if sine theta is positive, then cosec theta will be also positive. Rest other 4 trigonometric ratios will be negative. Here both sine and cos will be negative. If sine and cos both are negative, then tan theta and cot theta are positive. And here we have perpendicular positive and base negative. So at perpendicular here it will be negative and base is positive. Perpendicular negative and base positive. So since base is positive, cos theta and sec theta both will be positive. So what we come to the conclusion is, here all sine, tan, cos. Here all the trigonometric ratios in between these angles means 0 to 90 degree, they will have positive values. Here all the trigonometric ratios means here only sine theta and cosec theta in between 90 and 180 will be positive. Here tan theta and cot theta is positive, and in between 270 and 360 degree cos and sec are positive. All sine, tan, cos, or in short we say add sugar to coffee. So this is how we understand what should be the sign of the trigonometric ratio according to the values. And this is one period, that is from 0 to 2 pi or 0 to 360 degree. When we go back, when we go again more than 360, the value repeats. So this is how we understand the various values of the trigonometric ratios in different quadrants. In my next video, I shall give you some examples to how to find out the value of the trigonometric ratios which are more than 360 degree, and also values which are more than 180 or in between 180 and 270, 270 and 360, and so on. I hope you will understand, you will have understood what I have explained. If not, please comment in the comment box and give suggestions so that I can make much better videos in my next session. Thank you. See you again.